All right, so we're going to go over week 10 and 11. That's the main focus of this Zoom for today. Just a reminder that after you finish your work with this one, make sure you submit it here in the week 15 folder where it says Tuesday, 5/11, week 10 and 11 there. You should see the ed puzzle here that you just clicked on. And again, if you were watching this, that means you weren't on the Zoom or in class, and so you're making this up. So as I go through these problems, just remember that I am focusing on folder A for this one, which is, again, the final review. So when you go in here to week 10 and 11 final review for this assignment, this is basically we're starting our actual final review a few weeks ahead of time, just so that we're pretty solid by the time we get there. So when you remember that this is in the third packet, so if you don't have the third packet, you're going to need to go to the library and pick this up. And again, it's all the way in the back of the third packet, starting with week 10, and each week has its own page. Say week 11, 10, 12, and so on. And the first assignment is just week of 10 and 11. So just, again, remember to pick that up at the library. And also, if you guys go back into this folder, you'll notice an ed puzzle here at the bottom. This is Miss Menard actually going through every single problem in that packet. So after you try the problem, you could look here, and she's going through every single one. Okay. I encourage you guys, try it on your own and then look. Don't just watch and copy and kind of binge watch it. Okay. Best way to learn is actually try it yourself first and then give it a shot and then go ahead and review it. Okay. So we're going to focus in on the week 10 here first. And you can see this is all about just factoring review. So we're going to focus on these first few types of problems here. All right. So let's say that the first one is kind of a GCF problem where I'm actually having to factor out a GCF. So let's say I have 3r cubed plus 15r squared plus 24, we'll say minus 24 r. Actually, matter of fact, let's say we've got r to the fourth, r cubed, and r squared. Okay, well, first thing I want to do when I factor this out, again, key thing is I'm factoring, is look to see if there's a common factor between all the coefficients. And 3, 15, and 24 all have a common factor of 3. Okay. And then I look at the variables and say, okay, what's in common between all the variables? Well, they all have at least r squared. So that's my greatest common factor, is 3r squared. Now I need to write out the factors, or the terms in the factor. And I say to myself, okay, 3r squared times what gives me 3r to the fourth? Will that be r squared? Then 3r squared times 3, oops, sorry, not 3, times 5r will give me the second term. 3r squared times minus 8 would give me the third term. And now with that, what I want to do is see, can I use the x to factor it out even further? Okay, well, negative 8r squared there, 5r there. Are the two numbers that multiply to negative 8 and add up to 5? No, there isn't. So that's all you can do. There's nothing else you can do there further than that. Okay, so the problem I want you guys to do is let's say 4r to the fourth plus 8r cubed, let's say minus 28r squared. Okay. Okay, so let's go over the next one. Okay, the next one we're going to look at is very similar. Okay, so let's just say that I've got 2r cubed plus, 10r squared. And then we'll say minus 28r. Okay, so first thing I look for is a GCF. The GCF here would be 2. Okay, that's the common factor, and they all have 1 r. So 2r is going to be my GCF. Then I write in the factors here. So 2r times r squared, 2r times 5r, and then 2r times minus 14. Again, take this over here to the side. See, can I factor it? 14r squared and then 5r. Well, those two numbers, I can find two numbers this time, and it would be 7r and minus 2r. Okay, so now what I can do is factor this out one more step. Now remember that if it's just 1 in front of your square term, then I don't need to do the box here. I can go straight from here to the factors. Okay, so here, for the first one, 7r, it's going to be r plus 7. and then r minus 2. All right. And I'm not going to do this. I'm not going to write r equals -7, r equals 2, because it didn't ask me to solve it. It just asked me to factor it. So that's my answer. I'm done. I don't need to write anything further than that. Okay, so the one I want you guys to do, let's do 3r cubed. Let's say minus 21 r squared. And then we'll say minus, let's say, what do we want here? We want minus 54r. Okay, so I want you guys to find what's in common between all those and see if you can factor it. Okay. Next, so now we want to look at differences of squares and sums and differences of cubes. All right, so let's just say I've got x squared minus 25. Just remember that number in front of the x squared, by the way, is a 1. Okay, this is a difference, meaning subtract, of two perfect squares. 1 and 25 are perfect squares. And for example, perfect squares are 0, 1, 4, 9, 16, 25, 36, 49, 81, and so on, okay, 100. These are all perfect squares, numbers that I could multiply one number twice to get that number, right? So here, if I have that, I can go straight to my factors, okay? I take the square root of the first one, which is x, and the square root of the second one, which is 5, and then the sign will be plus and minus. So then if I have 9x squared minus 16, square root of the first one, which would be 3x, square root of the second one, which would be 4, and it's plus minus. Okay, so the one you are going to do, and again, make sure, can I GCF, right? So let's say I've got like 8, say I've got, 8 and 32, right? Well, I could factor out an 8 from both of those, and I get 8x squared minus 4, which means then I can do x squared, or I can square root both of these, and I get x minus 2 and x plus 2. Okay? All right, so the two I want you guys to do are 9x squared minus 25, and then you're going to do 4x squared, let's see, minus 36. And by the way, look for a common factor here. Look for GCF first before you do that perfect squares. So I know those two are perfect squares, but I still want you to look for a GCF first. Okay, the next one is going to be factoring by grouping. Okay, so here's an example I'm going to go over for factoring by grouping. Remember with this one, you're going to split it down the middle. And I believe this is actually supposed to be cubed, and this one's squared. Sorry. Okay, I'm going to split it down the middle, and what I got to do is find the GCF between these first two numbers. So that would be 3x squared there. Okay, so if that's 3x squared, okay, so I chose to do something a little different here, just because I didn't feel like that was going to help you with this one. So again, I start with the left side, factor out the GCF, so here it would be 4 this time. And so 4x squared is the GCF. Okay, so for the first one, it would be 2x. And then for this one, it wouldn't be 2x, it'd be just x. For the second one, it would be 2. Okay, so x plus 2. And so now what you do is you take the part that the new factor here, the x plus 2, the part that's in the parentheses, and you rewrite them over here. And now what you have to do is figure out what is the GCF that goes here. So what do I have to multiply here times x to get x? Well, that'd be just 1. So then 1 times 2 equals 2. And these won't always be the same. Sometimes they'll be different. Like this might be like 2x plus 4, which would make this 2.
So basically you have to figure out what number do I have to multiply here times that to get to this term, okay? So now what you do is you take these two GCFs and that becomes your first factor, 4x squared plus 1. And then you basically just take one of these factors up here and write it down here as your second factor. Okay, so that's how you do that. So here's what I want you guys to work on. So go ahead and split this one and factor that out. Okay, next thing we're going to focus on is this last page here. We're going to focus on what are the roots here and creating an accurate equation. Okay, so if I have a problem that says find the roots, or it could be solutions, okay? Or it could be the x-intercepts. What are they? Okay, let's just say that the equation is x squared minus 7x plus 10. All right. Well, to find the roots, solutions, or x-intercepts, okay, in this case it asks for roots, right? So roots are written this way. You just literally write the number. Solutions, you write x equals that number. X-intercepts, you would write the number, comma, 0. All right, so roots, I'm just literally going to write out the number. The way I'm going to do that is I'm going to factor this out. And essentially what I'm going to do is set this equal to 0, and we're going to factor it out with starting first with the x if we can. If you can't use the x, you might have to do quadratic formula. So I'll do the x, get 10x squared, negative 7x. My two numbers are going to be minus 5x and minus 2. Okay, so now in here I write x minus 5, x minus 2. Now I know that my first root is going to be 5, my second root is going to be 2. And those are my roots, 5 and 2. Or I can just write x equals 5 and 2. Okay? So now what I want you guys to do is y equals x minus 9. And we'll go minus 18. Actually, we'll go plus 18. Okay? You guys find the roots. Okay. All right, now we'll look at creating an accurate equation. It could be they give you the x-intercepts like this, or you might get a graph that looks like this. If it's a graph, you literally just are going to write out those numbers by looking here, and notice those bounce, by the way. Okay, if they're x-intercepts, then you just already have the numbers, all right? And you might have one other point. Like in this case, it's 3, negative 12. For this one, you're going to want to use that y-intercept, okay? So let's say that they give you 2, 0, and negative 5, 0, right? Okay, those are the x-intercepts. Or it might be the graph looks like this. It might be like f5 over here, and 2, right? And let's just say that it goes up, comes down, and there's your graph, right? And actually, it might go the other way. We don't know. Okay. Actually, let's go the other way because we don't know if it's negative or not. We're just going to assume it's going up. So that means that 2, negative 5. I know this isn't totally accurate, but the point is that you got 2 x-intercepts. All right. And let's say that you've also got, it gives you another point, right? Like, I don't know, like 8. Let's just actually use a y-intercept. Okay, and let's say that y-intercept is 20, 0, 20. All right, or 0, and let's say minus 20. Okay, so now what I'm going to do is first, as I set up my equation, I need to put an a value in front, and I'm going to set up the factors. Okay, the factors come from your x-intercept. So if that's plus 2, then I put x minus 2. Negative 5, I will put x plus 5. Now I have to solve for that a value. And what I do is I take that point they give me. It could be the y-intercept. It could be another point. You can see that in this problem right here, it's 3 and negative 12. It's not a y-intercept. And I plug that in. Okay, so now I get negative 20. And then here I'm going to plug in the 0. So basically I'm plugging in the y for the y and the 0 for the x. Okay, so now what I do is I simplify and multiply these two. So this is going to be negative 2 times 5, which would then end up being negative 10a. And then solve for a here. So divide by negative 10 and a equals 2. Okay? So now all I have to do is now plug in that a value right here into the equation. So 2 times the x minus 2 plus 5. But it also asks you to put it in standard form. So if it's put in standard form, then what I have to do is first multiply this part, and I'll do that by using the box. So multiply these out, get negative 2x, 5x, negative 10x. Okay, so then I get x squared, and add these two terms, plus 3x, then minus 10x. And then the last step to get it in standard form is that I've got to distribute this factor or this a value to each term. So now I end up with 2x squared plus 6x minus 20. All right, then you're done. Okay? So now what I want you guys to do is going to be x-intercept is negative 3, and let's say 2. And the point I want you to plug in is going to be 0 and 12. All right, go ahead and set up your equation and find it in standard form. And also, on a side note, after you find this equation, is let's just say that it gives you the root are 2 and the other root is, the other root bounces at minus 5. So when I set that up, I'm going to put x minus 2 and x plus 5, but then don't forget this has to be squared. Okay? Has to be squared, which then ends up being that I have x plus 5 and x plus 5 again. Okay? So that's just a side note. All right? That's it.